Hi everyone! Welcome back to my channel where we do some virtual trigonometry learning. Today we're going to learn about transformations of sinusoids. So last time we learned what the sine graph and the cosine graph look like. Both of these are what are called sinusoids.
O-I or I-O? O-I.
Sinusoid is a graph that can be derived from the sine graph. So like I said, cosine is really just sine shifted over pi over 2. That makes it a sinusoid. It's just a transformation on the sine graph. So any graph or function that can be derived from the sine of theta function is called a sinusoid. And it's going to be periodic or repeat the same shape, repeat the same pattern after a certain distance of its domain, and have waves that oscillate. A good place to start when thinking about sinusoids is starting with the original sine graph. Looks okay. But now, the same way that we can transform other functions by shifting them up, stretching them vertically, shifting them left and right, we can transform sinusoids too. So let's say I have a function that is sine f of theta is sine of theta plus pi over 2. So, similarly to other transformations of functions, my plus pi over 2 is on the inside of my parentheses attached to my domain variable, my input variable theta. So this is going to shift my graph horizontally by a factor of pi over 2. So, also the same, when you add pi over 2 to this function, it actually is going to move your new function to the left pi over 2. So it's kind of the opposite of the sign that's on the inside. Because if I were to solve for the theta that I need in here to find the same y point, you have to subtract pi over 2 to the other side to get rid of it. So when I put theta in for 0, I can make a theta, f of theta table. When I put in 0, I'm going to get sine of 0 plus pi over 2, or sine of pi over 2, which is 1. When I put in, let's say I put in pi over 2, I'm going to get sine of pi over 2 plus pi over 2, or sine of pi, which is 0. When I put in pi, I'm going to get sine of pi plus pi over 2, or sine of 3 pi over 2, which is negative 1. When I put in 3 pi over 2, I'm going to get sine of 3 pi over 2 plus pi over 2, which is sine of 2 pi, which is 0. And then when I plug in 2 pi, I'm going to get sine of 2 pi plus pi over 2, which is going to bring me back to my original pi over 2 if I'm going around the unit circle. So I'll be back to sine of pi over 2, or 1. And you may think that this looks pretty familiar. This is also the graph of cosine. Ooh, it's kind of mixed up. So that's how you get the cosine graph as a transformation from the sine graph. Let's do 2 sine of 1/2 of theta. So this 2 in front is going to be a vertical stretch, right? The same way it is for another function if you have a multiplier on the outside of your whole function. So this 2 is going to stretch our sine curve vertically. So instead of going from -1 to +1 as the range, our humps and valleys are going to get stretched, and they're going to go from -2 to +2. The 1/2 in here is going to change the period, or the length of one total wave. And so our period is going to be stretched out by a factor of 2. It's going to get longer, and I'll show you how. So again, making a table can be really helpful. So we have theta, and we have f of theta for our input and output table. I'm going to start with 0. Now when I put in 0, I get sine of half of 0, which is still 0, and sine of 0 is 0 times 2 is still 0. So I'm going to be at the same point.
Let's graph that real quick.
And then if I put in my next kind of like main point, which would be pi over 2, I'm going to get 1/2 of pi over 2, or pi over 4, right? And sine of pi over 4 is kind of a gross number. It's root 2 over 2. And that times 2 is just plain root 2. But I don't really want to plot that, so I'm going to go to the next one and see if there's a nicer one that I can plot. And if I need to, I can go back and plot this one. The next one, if I put in pi, right? Sine of 1/2 of pi, sine of pi over 2, ooh, I know what that is. It's 1 times 2 is 2. Okay, that's a nice number. Now if I do 3 pi over 2, then again, I'm going to get 3 pi over 2 on the inside times 1/2, which is 3 pi over 4. Don't really want to do that, but whatever. It's also 3 pi over 4 is also root 2 over 2. Sine of 3 pi over 4 is root 2 over 2. Times 2 is also root 2. But again, don't really want to plot root 2 on there. And I can keep going. And so now I'm going to go over to 2 pi. And now I know, okay, the sine of 1/2 of 2 pi, or the sine of pi, is 0. Times 2 is 0. And then I drew this kind of big. That's okay. And so now I'm gonna start to plot these ones. So I want this one, and this one, so I don't have to plot the root 2's, because that's like just not a nice number. So now I have 0, 0, I have pi 2, and I have 2 pi 0, okay? And so now, like, I think I'm gonna skip all of the pi over 2, 3 pi over 2, etc. And now I'm going to jump to 3 pi. If I do sine of 3 pi times 1/2, so what's 3 pi divided by 2? 3 pi over 2. Sine of 3 pi over 2 is -1, times 2 is -2, okay, like that. And then if I put in 4 pi, then I get 4 pi divided by 2 is 2 pi. Sine of 2 pi is 0 times 2 is still 0. And now I have something that looks like a normal-ish sine curve. I have the whole thing, one full period. I ended at the same place that I started. But this period, you'll notice, is stretched out, right? Usually one full period is from 0 to 2 pi. Now it's from 0 to 4 pi, right? This 1/2 multiplied our period by 2 and made it twice as long, twice as wide, stretched it out. And then this 2 out here made us go from 2 to -2 for our range, instead of just 1 to -1. So we've stretched it vertically and horizontally. Boom, clean whiteboard. Well, let's say we just had sine of theta plus 1, for example. Right? So sine of 0, plug 0 in here, is 0, plus 1 is 1. Sine of pi over 2 is 1, plus 1 is 2. Sine of pi is 0, plus 1 is also 1. Sine of 3 pi over 2 is -1, plus 1 is 0. And now sine of 2 pi is 0, plus 1 is back to 1. So, it's the same curve, just shifted up 1 unit. So before, our midline was at 0, like kind of if we wanted to cut our sine curve in half horizontally. And now our midline is at 1, which is also our vertical shift. So, in general, when we're transforming sinusoids, they follow a certain pattern. A is our vertical stretch, which also impacts our amplitude. Amplitude is the height from the midline to the top of a peak, or from the midline to the bottom of a valley. Either or. It's not the total height, it's the height of the midline to one top of the hump. Not from the lowest point to the highest point, but from the middle point to the highest point, or from the middle point to the lowest point. The height of our wave is our amplitude. And then we also have B. This is going to impact our period. So our period, or how many thetas, how long it takes for us to complete one wave, is going to be 2 pi divided by B. Because our normal period is 2 pi, but if there's a change, the B is going to impact it in the inverse way because it's on the inside of the parentheses. It's attached to the theta. So the same way when we did transformations of functions, everything attached to the x did the opposite. Same thing here. So the period of our sinusoid is 2 pi over B. So like for example, before when it was 1/2, 2 pi divided by 1/2 is really 2 pi times 2, which is 4 pi, which is why our full length of our sinusoid took 4 pi. And that always has to be factored out of our theta plus c. It has to be outside of the parentheses. This c is going to be our horizontal shift. And it's the opposite of the direction. So like if it's plus something, it's to the left. If it's minus, it's to the right. And then D is our vertical shift. So that's moving it up and down. And if it's as it looks, so if it's +2, you're moving it up 2. If it's -2, you're moving it down 2. So this is our general form for transformations of sinusoids. Yeah. Here, I'll give you a practice problem. Try graphing the sinusoid. F of theta equals 3 sine of 2 theta plus pi, all minus 1. Pause the video, and then I'll show you the solution after. So I started graphing what I knew. I know that because my B value is 2, my period is 2 pi divided by B, or 2 pi divided by 2, my period is going to be 1 pi. So I graphed on my theta axis from 0 to 1 pi, and then I cut it into chunks. So I know I'm going to need a pi over 2 is going to be my halfway point, and then I need my quarter points, which are going to be pi over 4, and 3 pi over 4, which are halfway between my 0, pi over 2, and pi over 2, and pi. I also know that my midpoint, my midline, is going to be shifted down 1. Usually it's at 0, and now my midline is going to be shifted down 1. All of my y values, all of my f of theta values are going to be shifted down to -1. So that's going to be my middle point. I also know that my amplitude is 3, so that means my distance from my midline to my top of my mountain is going to be a distance of 3, so it's going to go from -1 to 2. And then it's going to go down from my midline to my low point, which is going to be down at -4. This should be down at -4. And then I also know that I've shifted pi units, but because my period is 1 pi, it doesn't matter. That shift doesn't make a difference because because if my period is pi and I shift the whole thing pi, it doesn't matter. Like it's gonna repeat every pi. So if I shift it a whole pi, it's gonna be the same wave again and again. So that's actually not really relevant in this situation. What I did to figure out what my wave would look like is by plotting the points that I knew. I started plotting points in my theta, f of theta column, and I just kept getting -1 for my common ones, which makes sense because that's my midline. And those are kind of like my middle points, my first point, my end point, and the one in the middle. And then I know that my sine curve looks like this, but just to make sure that I wasn't going down or something like that, and if I wasn't sure that I was going to be going up right away, I tested pi over 4. And when I plug in pi over 4 here, you get pi over 4 plus pi, which is 5 pi over 4 times 2 is 5 pi over 2, which lands on the unit circle the same place as normal pi over 2. Sine of pi over 2 is 1, times 3 is 3, minus 1 is 2. And then that means that my other one has to be down at negative 4, but I could also plug in 3 pi over 4 and confirm. Thanks for tuning in to this video on transformations of sinusoids. Keep checking out our channel for some more trig videos. Thanks.